Morning from a very wet and rainy Cape Town. I hope everyone else is doing well. I myself am Tamara Lucas. I am the product manager at Lasec here. I deal with the cold chain instrumentation, but you're not going to see very much of me. Today we'll be hearing a lot from Harry. So Harry's from the Higher Biomedical UK team. He's the product manager for ultra-low temperature incubation and clean air technologies. So he works a lot with Hire's R&D team in China. So he focuses a lot on technologies needed in the field, where the kind of the world is going with technologies, and what to keep in mind. So without further ado, I'm going to hand over to Harry.
Thank you for such a lovely introduction, Tam. As Tamara said, my name's Harry. I'm the core product manager at Higher Biomedical UK, and again, that covers ULTs, incubation, and clean air. Primarily, my specialty has always been in cold chain, and more specifically these days, ultra low temperature. So I'm quite involved with the R&D team, and also over Europe and America as well, occasionally speaking to customers, learning more about where the market's moving and what the requirements are. I think as we move more towards hopefully a more sustainable future, this is reflected in the market and what people are asking for. So the technology is moving more towards helping to meet that sustainable future and helping to sort of reduce the impact the cold storage has on the planet. As you all know, -80 freezers have historically been very power hungry, very energy inefficient, and the amount of change I've seen over the 8 years I've been working with Hire to move to a more green focused design principle, it's really reflected in a lot of the newer technologies that have been coming out, and this whole presentation I'm going to be showing to you today will be focused on that. And that's the sort of sustainability through innovation that we've been working on very, very hard at Higher Biomedical. And what do I mean by that? Well, one of the sort of the crown jewels of Higher Biomedical is the R&D team. A huge percentage of the total head office staff are part of the R&D team. And a lot of work and a lot of resources go in to make sure that the products that are coming out of R&D are not only high in quality, but are really designed with this new green and sustainable mindset, where we want to help reduce the impact our products are going to have on the planet, and also help all of you reduce the impact your storage requirements and your laboratory are going to have. So just a quick little bit about the innovation at Higher Biomedical. We're operating over 150 countries and regions. I think this number is actually old. I think it's close to 1,500 individual intellectual property patents, over 800 R&D staff, and now over 1 billion end users. And that's really something we value quite highly, is direct communication and feedback from users. This is definitely helping to push us more in the direction of the sustainable front, which is that users want and people want to be more sustainable, want to reduce the impact their laboratories are having, and having that feedback and having that information is very valuable to us. We are, in fact, the first companies to have a lot of our cold chain as MDR are -80 freezers. In fact, and you may not know this, but the Higher Biomedical group is made up of several different companies. We really believe in sort of bringing the best of the best together, and that's really reflected in this company structure as well. So I'd say one of the first things that we moved to is hydrocarbon refrigeration across pretty much our entire cold chain range. And what this means is the refrigerants and the refrigeration I'm talking to is, it talks about what makes the refrigeration system tick. It's something that can be used to cool the system down. A refrigerant is any chemical that you can very closely control the boiling point of by changing the pressure and everything. So it's what circulates around the refrigeration systems to help keep everything cool. Now, historically, and not so long ago, 10, 20 years ago, chemicals like chlorofluoro and hydrofluorocarbons were used, and these were very effective refrigerants, but their main problems were they were ozone depleting, which means once they get into the ozone layer, they cause damage. but also they have a very high global warming potential. And a GWP, or global warming potential, refers to the effect anything, in this case refrigerant, is going to have on global warming, or on climate change. We consider, and that's normally its ability to reflect the heat and light from the sun. CO2 is referred to having a GWP of 1, which means it's the base mark. It's the 0 point on the scale. And some of these refrigerants, the older refrigerants we're talking about, can be, GWP of 1,000 or 2,000, which means they have a 1,000, 2,000 times more potential to cause global warming than CO2 itself. Now, obviously, you can't design sustainable systems with those kind of refrigerants in mind. And thankfully, the industry's made a slow progress towards replacing those with pure hydrocarbon refrigerants, which have GWP scores closer to 1. So they're hundreds, if not thousands of times more sort of low impact than traditional refrigerants. Now, we made that move quite a long time ago. We're quite proud of that. We made the move for a lot of our refrigeration systems to move to hydrocarbon. Now, it's not just a benefit from the impact side. There's also superior energy efficiency. So making that move allowed our first generation of the newer J series to reduce their energy consumption. And not just their energy consumption, but it was the amount of noise they're generating and also a performance increase. So the move to hydrocarbon was a sustainable one, but it didn't come with a drop in performance. And when I want to talk to you about the innovations we make it higher and the changes we've made to our refrigeration systems, we make sure that when we make these sustainable moves, there's no compromise on performance and there's no compromise on the quality that you're used to from our team. So hydrocarbon refrigeration really was one of the big steps we made first. And we were one of the first people to move our entire ultra low temperature range to hydrocarbon. Now, this, as I mentioned, came with performance, energy, and noise level improvements. And it was, when I joined Hire, one of the first big things that happened. Following that, the next big change that we brought to market was the on-demand cooling. You may be familiar with our BP and BPT series freezers. Now, what I mean by on-demand cooling. So a traditional -80 uses a set of compressors, a high stage and a low stage, to achieve -80. And that's by a series of cooling of the low stage and then the low stage cooling of the whole freezer. Now, and that's just a layman's description. If you speak to an engineer, it's much more complicated than that. But the main issue is, in previous generations of freezers, the compressor was either running at full speed or it wasn't running at all. And you can normally hear this when you're near a -80 freezer, where you hear a click from the relay and then you hear the compressors running at full speed. Now, the issue with this is you tend to overshoot the temperature. So what would happen is your -80 freezer would warm up to -77. The compressors would turn on and they would draw the freezer all the way down to -83 and turn off again. And that obviously uses a huge amount of power, and you've also overshot your target temperature of -80. Now, this is traditionally how a normal cascade refrigeration system works. And what we brought to the market in our new BP series was the on-demand cooling that you can get from something called an inverter compressor. And the main difference between the inverter compressors and the normal compressors in a -80 freezer is, instead of running either not at all or at full speed, the compressors can have their speed controlled by the freezer. And the massive benefit of this allows the freezer to deliver exactly the amount of cooling required to just reach the target temperature. And not only reach it, but allows the freezer to increase power when there's higher demand, when the door's been left open or warm samples are being loaded, but also when the freezer's not under any stress and the door's shut. It allows the freezer to use a very low amount of power to maintain the temperature at exactly -80. If you have a temperature monitoring system, you can see the difference between an inverter freezer and a standard freezer, because the temperature uniformity on a cascade system is ±5 or 6 degrees. On an inverter series, it'll be ±3 degrees. There's a much tighter tolerance. And this doesn't just allow the freezer to be more uniform, it comes with huge benefits in terms of energy efficiency too. The inverter compressors allow the freezer to deliver exactly as much power as it needs, but it also makes the freezer much quieter as well. We saw, a drop by as much as 9 decibels in terms of noise levels, which means in a large freezer farm, or when these are inside the laboratory, that it makes for a much nicer laboratory working environment. But the energy gains were quite huge here. So by moving from a standard system to an on-demand inverter system, there's a huge gain in performance, and there's a huge reduction in the energy usage. And this is definitely a huge part of what made our next generation freezers much more efficient. And this is a theme that's continued sort of throughout all of our cold chain. A lot of our refrigeration is moving towards inverter compressors because it allows us to deliver on our goals to make more sustainable, low impact products, but also provide the quality and the increase in performance that we want to see in all of our products. So this graph here is just to show you a rough representation of how the difference between a standard compressor and an inverter compressor can be seen. You can see that the compressor speed will increase and decrease as the unit needs power, whereas on a standard compressor, because you're wasting so much power when it's not needed, you end up with much higher energy consumption. Where this first became apparent to us is the energy savings we're managing to make on our pharmacy refrigeration. So the HYC 1030 GT is one of our newer models, one of our advanced range, and it's moved to its full hydrocarbon refrigeration and using the inverter compressor system. And it's managed to go from around 5 kilowatts down to 2.2 kilowatt hours per day. Now, the extra bit of innovation here is that we've removed the door heaters, which were generally used to prevent fog forming from inside the fridge. Now, we've replaced that with our new triple paned low E glass. And what this allows us to do is prevent any fog, prevent any misting inside the unit, but do it in a way that has no power consumption associated with it, which is why we've managed to almost more than halve the energy consumption of this large fridge. Now, as I've said, we never want to give a sustainable option with compromising on performance. This new hydrocarbon inverter compressor system also boasts a massive increase in performance. So not only is the fridge higher performing, it has our new whole unit uniformity guarantee, which is the uniformity inside the fridge is rated for plus or minus 1 degree, which is 2 degrees better than the standard for pharmacy. Now, it achieves this by forming a convection current of cold air. If you look at the back of the fridge, you can see air slits, which is used to circle laminar air through, which allows you to not only recover very quickly from door opening, but also maintain a very high degree of uniformity. We did some temperature mapping in the UK at our offices, and the performance of the fridge was actually plus or minus 0.6 degrees Celsius, which is unlike anything else in the market. I think it's fairly comfortable to say in the pharmacy refrigeration range, there's not anything like this unit on the market. And it gives you all that performance with very, very low energy consumption and also very low noise because, it's using that inverter compressor system. So I thought I'd give you a case study from the UK, which sort of highlights the gain in performance and also the increase in energy efficiency and sustainability with our newer products. So a large university in the UK, Sussex University, came to us with an issue, which was their legacy minus 80 freezers were using far too much power, and it was costing them a large amount of money. Now, looking at the cost per kilowatt in 2021, it being 10 pence, it seems like a long time ago now, because the cost in the UK has actually gone up to around 24 pence per kilowatt. So it's more than doubled. So everything I'm about to tell you, the figures I'm about to give you, in the UK now would be twice as effective. So their legacy non-inverter, non-hydrocarbon refrigeration systems were using 20 kilowatt hours a day per freezer, and they were running 24 freezers as part of their freezer farm. Now, part of this move was to consolidate. They, as refrigeration has moved on, There's been a lot of gains in the insulation material, in construction quality. So you'll notice that larger capacity freezers are actually smaller than the old school, smaller capacity units. And that's just a gain that's been made with the increases in refrigeration technology as well as the insulation. So as you can see here, moving from their smaller legacy units to one of the newer large capacity inverter units, they go from 20 kilowatt hours per 24 hour to 8.2 kilowatts, which is half the energy. And each freezer provides a larger capacity. So they managed to actually go down from 24 freezers to 20 freezers because the newer, more efficient models provided more storage for the same amount of space. Now, if you look at the energy cost per year, £700 down to £290, it is a huge saving. You know, it's more than half. And when they did the calculations, Sussex realized they had a return on investment in just 7 years from transitioning to these more energy efficient products. So I think it's important with the argument about sustainability to know that you don't have to compromise. You know, it normally with sustainability, it's not only sort of a social responsibility, it also normally comes with financial benefits as well. And a lot of them are running costs. The price of electricity is only ever going to go up. So making sustainable decisions now will make financial sense even into the future. So we checked, and they, by moving to these new freezers, were saving 100,000 kilowatt hours a year. And that's £20,000 per year at these numbers. You know, in modern numbers, it'd be close to £40,000 per year. So I thought it'd be good to give you a little example of making those moves to a more sustainable product. And the innovations that Hire have brought to the market have real world applications and real world benefits. And the next one I want to talk about is our cryogenic freezer, our -150. So this has more recently had an upgrade to a much more efficient refrigeration system and a move to be the world's only hydrocarbon -150. A lot of those nasty HFC refrigerants are still in use today in the -150 cryogenic freezer market, and that's because they're convenient. You know, it's a very difficult temperature to reach with hydrocarbon. The R&D team at Hire Biomedical managed this. We're the first people to have managed it, and not only has it come with a much lower impact product, it allows us to reduce the energy consumption compared to our competitors by 1/3, which is more than a whole -80 a year more efficient than the competitors. In the UK, I like to say my favorite factors are -150 is a whole UK household a year more efficient than the nearest competitors. But I just thought I'd give you another example of how moving to an inverter hydrocarbon system, you know, the innovations that we've come are really pushing the design in the sustainable direction. And I think that's very important, especially if we all want to reach our sustainability goals going forward. One thing I'd quickly mention, I do a presentation on freezer care in the UK, and it's all about things you can do to minimize your impact and be more sustainable. So I thought I'd slide a slide from that presentation in, which is racking. And I personally think racking is one of the best things you can do for your -80 freezer. This is definitely something that I would consider to be a very sustainable move. Empty freezers cost a lot of energy to keep cold. Filling them with racking helps prevent that, and it also helps buffer the temperature when doors are opened or if there's a power failure. The racking helps to maintain the temperature inside the freezer and the temperature of your samples. It also makes things much easier to access and pick samples from. You don't always have to have cryo box racking as well. Metal bin racking is just as effective, and anything that makes the freezer more efficient, makes you use the space more efficiently, and lets you pick samples more efficiently, reduce the amount of energy the freezer uses, the amount of icing you get inside your freezer, and also means you can use the freezer space to its most efficient spot. So I just thought I'd mention that. Now, this product has occupied a huge amount of my time recently, and it may be new to a lot of you, but we've recently released a new -80 freezer, which kind of brings all the innovation we've put into sustainability into one product. And that's our Ultra Eco range of -80 freezers, which have just been released as the world's most energy efficient ULT freezers. If you go onto the Energy Star ranking, which ranks everyone globally, we are the top freezers for energy And the best part about the Ultra Eco is that it's delivering up to a 50% reduction on our previous generation of freezer. And that's the previous generation of freezer was the freezer that Sussex University went with because it was so efficient. So we're seeing a further 40 to 50% reduction on those figures, which I'll go into shortly. But with the 50% decrease, we've actually seen a 35% to 40% increase in performance. And with that, with our new sustainable insulation system, we've actually also seen an increase in the hold time during power failures. So this new freezer is bringing an ultra low energy refrigeration system. It's got an ultra low impact design, and it brings high performance. So there's no compromise in terms of performance when you're going for this more sustainable option. And it's a huge generational leap forward. It's not a small change we've made. The R&D team have worked very hard on this product. It's hundreds of small optimizations and changes that have been made to make this the world's most energy efficient freezer. And as you can see from these numbers, we're going from 8.13 kilowatts for our 700 liter down to just 4.16, which is a huge reduction in energy. And this is where we've brought the inverter compressor system to and everything we've learned to a more optimized place. So this new inverter system, the new insulation, the new technology controlling the compressors, everything's come together. Everything we've learned from innovating in the green space has been brought to this freezer. And as you can see, the energy consumption change is enormous. And that's also shown on our 830 liter. So currently we're releasing our 730 BPT and our 830 BPT, but there will be 500 and 900 liter models available. Just look at the graph. It's very clear it's not just a small change here. It's a big generational leap forward. And I think it's really put us ahead of the competition in terms of sustainability and helping laboratories reduce the impact of their cold storage. And if we just plot the lifetime CO2, and in this case, I've put 10 years, but you could do longer, 15, and it'll only get more efficient. This is based on UK figures. So I have a number which tells me how efficient the UK grid is, and I'm using that to convert between kilowatt hours and CO2. So for every kilowatt hour the freezer is using, how much CO2 is our grid producing? And it'll change based on the location, how much renewable energy you're using, how much fossil fuels being used. So this number may change, but here we have in green the new 730 BPT Ultra Eco and the older 729 BPT. Now it's important to know the 729 BPT models are still competitive today with the energy efficiency. And there's very few freezers which can compete with that model in terms of being a low impact storage solution. But the new 730 BPT's innovation brings it even further ahead. And you can see here, if you look at the CO2 which is the amount of CO2 of kilograms produced over 10 years, the reduction over the lifetime of the freezer, which is in this case 10 years, has been set at 2.5 tons of CO2. And when I calculated the equivalent of that, it's if I were to drive all the way from London to Auckland by car in New Zealand, which is a huge amount of CO2. Now, this is comparing it to a brand new modern freezer. If we were to go back to the case study with Sussex, these ULT freezers were using anywhere up to 20 kilowatt hours a day. In comparison to a 730 or an 830 BPT, they're using 4 to 5 times the energy. So when we talk about reducing the impact and being more sustainable, moving to these new ultra low impact freezers, these Ultra Eco models, massively reduces the impact your storage is having on the planet. But not only that, because of the gain in energy and the increase in performance, you can show that there is a real financial return on investment, especially over 10 years, especially over 15 years. When I looked at the cost of one of our smaller 300 liter models in the J series, which is our more economic range, and I compared it to the cost of our 730 BPT, by year 6 or 7, you have a complete return on investment. So not only has the 730 become cheaper, you also now have double the freezer capacity with a higher performance freezer. So it's a very important thing to take into account, the lifetime impact of a freezer, because the initial cost isn't the only thing to consider. It's the lifetime cost of the freezer. And that will be in either CO2 emitted from the grid or the cost of electricity for running the freezer itself. Now, again, when you compare to an older freezer, you wouldn't be talking about 2.5 tons of CO2. You'd be likely talking more around 10 tons. And when we've made comparisons to older models, we see the lifetime impact of this newer freezer is significantly lower. So this product is a great example of the innovations that have gone into place at the R&D team at Hire to help our customers meet their goals for sustainability going forward. But as I mentioned, performance is very important to us, and we would never want to sacrifice the quality and the performance you're used to from a Hire biomedical freezer. So the newer freezers use our new green LBA insulation. I mentioned hydrofluorocarbons previously when talking about refrigerants, but these agents are also used in insulation. So they're used to expand the gas and expand the insulation. Traditional freezer insulation for -80 freezers uses HFC, and it puts the GWP score of traditional insulation around 200, 250. I think it can be a little bit higher in some models, but that's a fair average. Our new LBA green foam is not only HFC free, it's non-ozone depleting, and it's non-toxic. This foam has a GWP score close to 1, so it can be up to 200 times lower impact than traditional foam. And the best part is it's a better insulator than traditional foam. So on the 700 and 800 litre models, you see an increase of up to an hour on the hold time from -80 to -50 during a power failure. And this can be fantastic for any regions that have power insecurity or anywhere prone to failure. This freezer will allow you to have an extra hour of time, which is a huge increase in time, and it doesn't come at the increase in width or increase in the size of the freezer. It's important to know too that racking will be compatible between the 730, the 729 and the 728J models, and the 800 litre, 500 litres and 900 litres. So if you have an older Hire freezer, the racking will be compatible as long as it's not a 490 or a 338J. So of course, hold times are incredibly important. ULT freezers are very critical parts of equipment. And again, this is another sort of green innovation we've made, to push our design more down the sustainability pathway. But not only have we increased the hold times here, there's a big increase in the recovery performance too. So the recovery times have increased anywhere from 35% to 50%. And what I mean by that is when the freezers are left open for a whole minute and then shut again, an important figure to keep in mind is how quickly the freezer will recover. And part of that is to do with keeping your samples stable and keeping them secure. And it's one of the reasons I think racking is so important, is because it helps with the recovery. Now, these figures are normally all measured at empty, which is the freezer at its least efficient. So the recovery times fully racked will be even more impressive. But we're seeing, again, 35 to 50% better performance, better recovery rate. So I think it's 27 minutes down to 17-minute recovery times. And on the 800s, 32 down to, I believe, 17. I'd have to double check the figures for you, but it's a huge increase in performance. Again, there's no compromise here. This also gives another increase in uniformity on our 700 litre model because of the more efficient inverter series and the more optimized control system. We're seeing a further increase in uniformity. So the 700 model can actually achieve plus or minus 2 degrees uniformity across the whole cabinet. So again, no loss in performance, even with a 50% reduction in the amount of power being used. I've kind of put everything together on this one page here, which is all the different optimizations, all the different changes that have been made to this product to make it more sustainable. And I think this is currently the crown jewel in the cold storage range for Hire Biomedical, and a lot of research and development and innovation have gone in here. So the team's very proud of what's come out. The green insulation, again, as I mentioned, 99.9% better for the planet than traditional insulation. 20% better insulation, which is what gives you the extra hour of warm-up time, as well as providing 10% of the energy efficiency gain too. So it's not just a hydrocarbon refrigeration system. It's not just the inverter compressors. You know, moving to a greener, more sustainable installation has also contributed to the energy efficiency. And this is why we call it our ultra low impact model, because it has an ultra low impact on the planet. And traditionally, when you walk into a building or you look at the energy rating of a building in science, it's always the lowest rating because -80 freezers use a lot of power. But not only that, it costs a lot of energy to keep them air conditioned as well. -80 freezers throw out a lot of heat, and that heat has to go somewhere. So it's very easy to not see the extra energy it's costing you for older freezers. They may be running at 18 or 20 kilowatt hours, but that's only when they're well air conditioned. If you turn the air conditioning off, you know, the amount of energy they use will increase. So it's very easy to sort of forget that and lose the extra bit of efficiency in your calculations. So it's important to think, you know, not just, oh, with these older freezers, how much energy is the freezer using, but what sort of strain is that putting on the air conditioning system? So these newer freezers, being more efficient, put out far less heat as well. So you're putting less strain on your air conditioning system too. And that's another sort of hidden sustainability pitfall that you can run into, which is if you keep your room at 19, 20 degrees, then of course your -80 freezers are going to run lower energy. However, you're just moving the burden of energy onto the air conditioning system. So moving to a lower impact model not only reduces the freezer's impact, but also the impact of your air conditioning system too. Now, one thing that has changed, less about sustainability and more about ergonomics with our new freezers, is the new fast re-entry system. So occasionally when you're opening and closing at -80, the freezers will form a vacuum and it will lock up. And you have to wait for the pressure equalization port to allow you back into the freezer. With these new -80 freezers, and this will roll out to our J series and our older BP models as well. We have our new fast re-entry electronic valve, and this has reduced the maximum lockout time by up to 80%. So the most time you should be ever locked out of your freezer is up to a minute, and that's the absolute maximum. This new valve is much more efficient, it's much faster, and it allows you to get quicker access to your samples. So you should be locked out the freezer much less time. So, and the last thing to mention, obviously, lifetime costings. And I will always bang on about it because I think I've always been very passionate about the sustainability side of the argument. You know, moving to more energy efficient freezers, I think everyone should be doing it. Not only does it makes a huge amount of sense to reduce our impact on the planet, you know, we want to preserve it for future generations, and being more sustainable and being more mindful is a great way of doing that. But the argument is always already there from the financial point of view. So if you're looking to buy, you know, if you're looking to replace older models as part of a rolling replacement scheme, or you're setting up a new freezer bank, if you look at the lifetime costings of moving to a more energy efficient model, the return on your investment will be much faster, especially if you're justifying the cost of replacing older freezers, and especially when you're thinking about the cost of repairing older freezers. After 10 years, you know, things will start to break on a -80, repairs need to be made, and you start sinking cost into a freezer. Now, by moving to a more energy efficient model, you can get back to being in the green in terms of investment in the model much faster by it being more efficient. And if you're making the investment in a new freezer room and you want to justify that too, moving to a more efficient model will help you not only reduce the burden of the running costs year on year, but also get that return on investment much faster. You know, I think it's always important to have both sides of the argument, because I think sometimes cost can get in the way of sustainability. And with the way these units have been priced, with the way they've been designed, we want to make it as easy as possible for people to make that green choice and not feel pushed to make a less efficient choice for financial reasons. Here, I just thought I'd put on screen the Energy Star rating for our two highest rated products. So right at the top, Energy Star are the 730 BP and the 730 BPT models. Currently, the unit's only available as BPT, which means it's only available as a touchscreen. However, that may change in the future, especially as we bring out more models. Now, the freezer below the 730 is our 830. That's because the 830 model is still more efficient, despite being a larger freezer, than every other freezer on the market. So it allows you to make a consolidated storage decision, like Sussex University did, but still have incredible energy performance and cooling performance too. And I really want to put that into perspective here. This is a very UK focused chart, and you may think the freezers that you're more commonly familiar with aren't on this chart. I do apologize, it's a very Europe focused chart here. And what we're looking at is kilowatt hours per day per box. And why I think that's so important is literages or capacity and how it's measured can really change amongst manufacturers, you know. And I think the best way of measuring a freezer is how many standard 2-inch cryo boxes you can fit inside. Because at the end of the day, that's the metric that determines the size of the freezer. People design their freezers around racking for 2-inch cryo boxes. Now, it may not be whatever you're storing always, but it's a good marker to compare freezers for freezers without worrying about the literage. So here you can see that per box, the higher Biomedical 730 and 830 BPT freezer are clearly ahead. And it doesn't seem like a lot, but when you're storing 600 or 500 boxes in your freezer, it builds up very quickly. And especially if you think these are the energy consumption per day. So we're talking over the course of a year, the amount of savings you're making per box are enormous. And you can see that compared to other manufacturers, you know, we're very much ahead of the game. And these are the figures that are pulled from Energy Star. So these are independently verified figures, and using manufacturers' own figures for how many cryo boxes can be fit inside their freezer. Now, if you use a slimline box, like a 2D, like a 0.83, or maybe even a slimmer, you can fit more cryo boxes into your freezer, and you can get better figures here. But I thought it's always best to go with the tried and tested standard cryo box here for calculations. Now, I do have more figures available. I have running costs available. They're all based on UK numbers, but it's easy to make the conversion. And I do have some literature I can share, which has all of our references for where the energy figures are taken from, where the power cost figures are taken from. So, you know, when talking about sort of higher products, but more importantly, talking about the ultra eco in this case, there's sort of some key takeaways, which are we always aim to be ultra low impact. And I think the new ultra eco freezer hopefully demonstrates that, which is we want to reduce the impact our cold storage is having on the planet. And it feels like a way that our R&D team and our team can make a difference, and not only make a difference from our point of view, but also make the difference from helping the labs, helping technicians, helping buyers make good purchasing choices without having to compromise on sustainability. And that's what ultra low impact sort of means to me, sort of means to hire, and also high performance. You know, we don't just want to be the most sustainable option on the market. We want to be the clear choice for performance too. And these new ultra eco freezers and essentially anything that comes out of the higher Biomedical factory will always aim to be the most sustainable, but also the highest performing. And following that is ultra low energy. So we always aim to keep our energy as efficient as possible. And hopefully I've given some good examples of that. You know, the innovation with the cryo freezer, the -150, being a whole household a year more efficient than the nearest competitor, and running on hydrocarbon gases. So we've replaced the more dangerous refrigerant with argon, which is completely inert and has a GWP of 1. And also with our pharmacy refrigeration, where we've replaced the compressor set and the refrigerants with hydrocarbon and inverter compressors to give that performance and the energy, but also by adopting new technology in the doors to remove the door heaters, which traditionally we're using 1 to 2 kilowatt hours a day, replace them with this new low E triple pane glass, which means there's no energy requirements for keeping the glass clear, and it means that we can deliver on our sort of sustainable design goals. So these are the key takeaways here. So I want to do from this presentation about sustainability. And I think the way we approach it, as I said, is through innovation. We want to make sure the way our R&D team is going, the way we're taking feedback from you, taking feedback from people using our products, is to make them more sustainable and help reduce their impact. But yeah, ultra impact. I like to bring this up. I like to keep mentioning this, and actually completely ingrained in my brain now. And the sales team in the UK have memorized this to no end. But it does hopefully encapsulate everything I've been talking about in this presentation.
Perfect. Thank you so much. That was really informative and really interesting to see the technologies from across the various types of cold chains. So from fridges to minus 150s to ultra lows. I think it's great to think of everything that goes into it, from actual running energy efficiency to what's needed with energy efficiency and how we can save on costs for air conditioning, for example. Yeah, so it's really interesting. Thank you very much. Questions. Let's start with this one. Carlos says, you mentioned the importance of in terms of efficiency. Can you comment on the maintenance of ULTs to ensure energy efficiency?
I think it's a really good question. And I think maintenance is one of those things which is everyone wants to do, but there's a cost implication, obviously. And part of the presentation I actually took the racking slide from is about freezer care. And one of my top 5 freezer care tips is maintenance. So a well-maintained freezer that's running at its best will be more efficient. And there's 100 different ways of looking at it. It could be keeping the ice down inside your freezer, and that means the seals operate more efficiently. It means that the door shuts properly, and it puts a lot less stress on the refrigeration system. Ice damage to the gasket means the freezer has to work overtime to keep the freezer cold. Now, it's not just that. It's looking after the freezer itself and keeping the compressor system in good condition and catching issues like fan motor failures early will mean the freezer runs at its most efficient for longer. And a well-maintained freezer is also much more resilient to failure. So it's not just thinking about it from an energy efficiency point of view, which a well-maintained freezer will maintain its energy efficiency rating for longer, but also a well-maintained freezer will last for longer. And if you look at reduce, reuse, recycle, it's the reduce which comes first, and that means we want to reduce how much product is ended up in landfills. And by maintaining your -80 freezer, you can actually extend its lifetime. And by doing that, you also contribute to being more sustainable. Maintaining a freezer means you can also catch issues before they become serious issues. So smaller issues like fan motors or handles, which could become compressor issues or PCB issues. By fixing them early with easy fixes, you can prevent more costly, expensive fixes in the future. The amount of energy and time that goes into replacing a compressor is enormous, and it's very expensive, and it's very specialist work. So by doing that, you're also being more sustainable. It's why I think maintenance is a necessary evil. It can be expensive, but it's definitely one of the top 5 things. Just below racking, I'd say preventive maintenance is number 1.
Great, thank you so much. Really appreciate that. Another question, sticking to the cryo-racks concepts. You touched on using cracks to assist in sample retrieval time. Is there an ideal time period for having the door or lid open to retrieve and store samples within ultra-low freezers or -150-degree freezers? And then exceeding that ideal time period, would it have a negative effect on samples and the ULT or -150-degree freezer itself?
Yeah, it's a really good question, because the ideal time is 0 seconds. the -80s use a tremendous amount of energy to reach -80. And unfortunately, air is very heavy when it's cold. You know, denser air is heavy. So when you open a freezer door, no matter what you do, and this is the whole point of these us using gasketed inner doors, is to prevent this. Cold air will fall out the freezer, and you spent a lot of energy cooling that air down, and the more air in the freezer, the more air will fall out. And one of the things of racking is it helps prevent that, because it fills that space with something. Now, the rack itself is conductive, so it will help keep your samples cool itself. So when the warm air gets sucked in, so when the cold air gets pulled out, it sucks warm air in from the outside, which is why you can see an increase in temperature on the freezer. Now, racking and also a good limb system, if you have one. I appreciate how expensive and difficult they are to use, but knowing where your racks, knowing where in the rack the box you need is, and knowing that your freezer is racked will massively cut down on sample retrieval times. And at like under a minute is the ideal. It's not always possible, especially when things aren't organized. It becomes very, very difficult. But not only is it more efficient in terms of retrieval and energy consumption from having to cool the freezer back down again, in a freezer failure, having a fully racked freezer is a night and day difference. I've helped customers empty freezers before, and when you have loads of frozen boxes, you have to chuck onto a trolley and move it to the new freezer. It's stressful, it takes time. You know, it takes 20-30 minutes to empty a whole freezer. With a racked freezer, you can have that freezer empty and decanted in 2 to 3 minutes easily. So it's one of the hidden benefits there. Is in a pinch, if there's a power issue or there's a freezer issue, you can get in that freezer and get it out in minutes. The issue with having the freezer door open, it's obviously you lose a lot of cold air, but the other thing is frosting as well as icing, and which adds to maintenance. Because there's 100 degrees difference between the inside and the outside of the freezer. When that humid air, and in more humid parts of the world, it's going to be worse as well. When that humid air hits the freezer, it will freeze instantly. And as that builds up, it puts more and more and more stress on the freezer door itself. So it will start pushing on the door. And if it gets into the gaskets, it will actually start to degrade the gaskets too. So if it opens up an air gap from the inside to the outside of the freezer, or if you're running temperature monitoring probes through that gasket, you actually make the freezer work harder, because it's not a sealed environment or there's damage to the. You'll make the freezer work harder, and it'll only introduce more icing. So keeping it to a minimum of a minute is ideal, and it's what all the recovery times are rated at. So if you're like, oh, my freezer's not recovering fast enough, is it because the freezer door was open for 5 to 10 minutes, etc.? And it's important to only access the parts of the freezer you're going into. So only access the inner doors of the areas you need to get to, because that'll massively help the freezer in terms of stability.
Great, thank you. It sounds like having a plan before you open the freezer and being in and out as quickly as possible is ideal, really. Right. Another question that's come up is we are running our freezer at -80 degrees Celsius, but I heard that you run it at -70 degrees Celsius for energy efficiency. We are concerned that increasing the temperature by that 10 degrees Celsius might affect samples. What do you recommend?
This might be one of the most asked questions I get. Everyone's familiar with the freezer challenge generally, which is running your freezers at -70. So there is a gain to be made in energy efficiency. That -70 to -80 is difficult, thermodynamically very difficult. As the freezer gets colder, it becomes harder to gain to drop temperature. So and it's the reason that the -150 technology is so difficult, is because you have to figure out new ways to get colder and colder and colder, as you can imagine. So it's a 4-stage process. A standard -80 is 2-stage. The -150 is a 4-stage process. So it's incredibly complicated. And it's the reason there's so few people making it, because it's complicated technology. But with -80 freezers, the unsatisfying answer is it's entirely dependent on your own samples. And it's good to look at literature on depending on what you're storing. If you're storing DNA at those temperatures, the DNA won't mind, right? So, but if you look at something like RNA, people swear by the fact that, oh, my RNA will only be stable at -80. Now there's not really enough long-term testing with a large enough sample size with every sample to tell you, is something stable at -80, is something stable at -70. I think it's an important distinction that groups need to make for themselves, which is, how thermally stable is your sample, and maybe making the decision of having freezers that are specifically for critical samples that are very temperature sensitive. So you could look to have one -80 that's for critical samples. It runs at -80, and then running another ULT freezer at -70 for the less critical samples. Because there are energy gains to be made. For older -80 freezers, you could be looking at 10 kilowatts. On the newer, more efficient models, you get something called diminishing returns, which is you gain 20 to 25% energy on the newer freezers by going from -80 to -70. And that sounds like a huge amount of energy, but when you're going from 5 kilowatts to 4 kilowatts and 4 kilowatts to 3 kilowatts, the energy gains are less. Now, with older -80 freezers, moving to -70 will give you a much bigger return on investment. And in the UK, it's been a big push to get for universities specifically, because they have so many freezers, to move to -70. But it also has to be done with a sort of pinch of salt of just be aware of how stable your samples are at these temperatures. Which is probably not the answer you were looking for, unfortunately, which is there's no right or wrong answer. You can definitely get energy efficiency gains. You just have to know how well your samples will tolerate that temperature change. Another thing to take into account is at -80, there's further to fall. So if you open the door, your freezer may get to -75, -70, right? And then recover to -80. Or during a power failure, it has to fall from -80 to -50 before you have to start to worry. But at -70, when you open the door, you have to be aware that your samples could be exposed to temperatures up to -60, maybe even higher, because there's less buffer. There's less temperature buffer there. And if there's a power failure, obviously, you're starting further down the curve. So all the figures given by manufacturers, including ourselves, are usually rated at -80. So you're giving yourself less far to fall if there's an issue with the freezer or there's a power failure.
Thank you so much for your time, Harry. Thank you, everyone, for your time. Yeah, I learned a lot. Hoping you did too.
Thank you for your time, everybody.